Welcome to this video lecture session. So in this lecture session, we are going to discuss the concept of hidden Markov model. So first, we are going to discuss about the concept of hidden Markov model here. So in short, we are calling it as HMM model. So today in this lecture session, we are going to see the concept of hidden Markov model, how it works by seeing that mathematical application, how we can solve the problem using hidden Markov model. We will see one small example. This is what the agenda for this particular session. So when you talk about hidden Markov model, it is one of the very common and most popular method, especially used for sequential as well as temporal data. Okay, so once again I repeat, so whenever you talk about the hidden Markov model, it is one of the very popular model used especially in the case of sequential or temporal data. It also used in a variety of machine learning and deep learning applications, as everybody of us knows, because mostly we are utilizing these hidden Markov models for finding out the distribution of events. Okay, why it is used very commonly and most popularly? Because it is very easy to implement and also it is very powerful to get the result, accurate result. Okay, that's why these models are very popular in various applications. Okay. Now, before we are okay, so going to discuss about hidden Markov model. So let me introduce three important terms. So one is Markov chain, and another one is Markov property, and Markov process. So if you understand these three terms, it is very easy for us to understand or correlate with hidden Markov model. Okay. So first of all, for example, you consider some sequence of events or chain of events. Let me say A, B, C, and D. Some sequence of events. Okay. If this chain of events, okay, will follow the property that the future state depends upon the present state. That means probability of B depends upon the probability of occurrence of C. So this is one of the very important property or Markov assumption we have to be taken into account. That means the probability of occurrence of the future event depends upon the present state or present event, not depends upon the previous or past state. Okay, so this is one of the very important considerations or assumptions. They are calling it as Markov property or Markov assumptions. If any sequence of states follows such Markov property or Markov assumption, we are calling such events as Markov chain. Okay, so if the process follows Okay, so if the process in which the distribution of event depends upon the present output or present state, we are calling such process as Markov process. So once again I will repeat. Okay, so before entering into the concept of hidden Markov model, so first we will see what is Markov assumption or Markov property. Then we will see what is Markov chain and Markov process. Just understand the terms and terminologies. Okay, so this is one of a very important assumption. We are calling it as Markov assumption or Markov property. That is, the probability of occurrence of the future event or future state depends upon the present state. That does not depends upon the past state. This is one of the very important assumption. If any chain of events follows such assumptions, we are calling such events or such chain of events as Markov chain. If the process follows the distribution of events in which the future distribution depends upon the present state, such a process we are calling it as Markov process. Okay. Now what is hidden Markov model? I already discussed this one. So it is used for computing the probability of distribution of events or states. So it is used for computing probability of distribution of events. Okay. Let us see some examples so that we understood in a very better manner what is hidden Markov model. Okay. So these states, before I am entering into the topic, so these states, for example, this state, this probability, we are calling it as transition probability. Okay, such kind of probability we are calling it as transition probability. Now, okay, so we are having some events, sequence of events. So we are interested in understanding some few events it is occurring sequentially. Okay, but that events are not visible. For example, for understanding purpose, that events are not visible. Okay, but it is giving some evidence. Every event is giving some evidence. Okay, some scenarios, the states, sequential states are not visible, directly visible or observable. I am unable to observe directly. Okay, in such a case, how I can understood what is happening? So I am checking what it reflects, these events. So it emits some evidence. Now I am observing these evidence from the states. From the observable state, I am trying to find the hidden state. So these states we are calling it as hidden state, and these states we are calling it as observable state. Okay, in some scenarios, the sequential states that I am interested to observe is not directly visible, or it's not directly available. Okay, such states we are calling it as hidden state. Then how I can observe that one? So from every sequence, I am having some observable state that might be the cause of that particular state. Okay, that might be the emission from that particular state. Because of that state occurrence, it emits some evidence. So I am observing that evidence. So from that case, I am trying to find out the probability of distribution of the hidden states. Okay, so these are all two states you understood. Okay, for example, so we already discussed about the weather condition examples, right? So there are, for our understanding purpose, we are taking some three weather conditions: rainy, sunny, and cloudy. Okay, so these are all the three states. Okay, so for example, for assuming that there are three weather conditions available: one is sunny, one is rainy, one is cloudy. So I am inside one hall. I don't know what is happening outside, or what is the weather condition outside. Okay, for example, assuming that. Okay, so what I am doing, I am observing that one person is entering into my room, okay, with the umbrella. Okay, so that I can assume that the outside of my hall, the weather condition may be sunny or rainy. Understood? So okay, so this is what, so these states are hidden states in my example. Okay, now these are all observable states. Okay, so the person is coming with umbrella, so that I am assuming that outside of my hall might be sunny or rainy. Okay, another one person coming with full formals and coats, wearing coats. Okay, so in that case, I assuming that, okay, whether it may be rainy or cloudy. Okay, so this is how from the observable state, I am trying to find the actual state. What is happening particularly in that particular time period. Okay, so this is what the concept of hidden Markov model. So these are all hidden states here, and these are all observable states here. Okay, so these kind of examples. Okay, so for such scenarios, hidden Markov model is the best practice to find out the probability of distribution of events in the hidden states. Okay, understood? Okay, very good example is we already discussed about part of speech tagging or POS tagging, right? For example, book that flight. Okay, so if the sentence is given like that, okay, first step it will take each individual word. For that, it will find out verb, okay, determiner, okay, and noun. So likewise, it will tag some particular phrases, right? So here, this is the observable state. So from the observable state, I need to find out, okay, POS tagging, it is related to the individual word that is almost hidden. So based on the tagging, we will go for further process like named entity recognition. It will go further. Okay. So in such scenarios, okay, so we can very well utilize these kind of models, hidden Markov models. Okay. So I hope you understood. So whenever we talk about the concept of hidden Markov model, okay, so what are all the things we have to keep it in your mind? So whenever we talk about hidden Markov model, so we have to consider two things. One is states, next one is probability. Okay, so whenever we talk about state, one is hidden state, first one is hidden state, second one is observable state. Okay, so whenever we talk about probability, so first one is initial probability distribution. So first one is initial probability distribution. Second one is transition probability. We already discussed what is transition probability. Next one is emission probability. Next one is emission probability. Okay. So whenever we are doing hidden Markov model for any applications, so mainly you have to keep it in your mind. It consists of hidden state, it consists of observable state, and when we talk about the probability or calculating the probability, so we have to consider initial probability distribution. What is initial probability distribution, and what is transition probability, and what is emission probability. Okay. Now we will take the same weather example, and from that we will see what is hidden state, what is observable state. We already discussed. Now we will see what is initial probability distribution, what is transition probability, and what is emission probability. Okay. So in the weather example, weather condition example, okay, there are three states. So one is sunny, next one is rainy, and another one is cloudy condition. Okay, so now I am going to draw the state transition diagram. Okay, so first of all I am taking sunny. Okay, so next one rainy, because three different states are there, and cloudy. Okay, so now what is the next probability of sunny if the current state is sunny? So it will be denoted by like this. So I am giving one probability. Okay, so I am giving one probability, that is 0.8. The probability of occurrence of the state sunny from the current state sunny is 0.8. Similarly, the probability of occurrence of rainy condition from sunny is 0.15. Similarly, the probability of occurrence of sunny condition from the rainy condition is 0.38. Similarly, okay, the other condition, the probability of occurrence of rainy or it maintaining in the same state, it is 0.6, for example. Okay. Now, from sunny to cloud, it is 0.05. Similarly, from cloud to sunny, it is 0.75. Okay. Similarly, from cloud to cloud, it is 0.2. Similarly, from rainy to cloud, it is again 0.2, and cloudy condition to rainy condition, it is 0.05. Okay, so this is the state transition diagram given for this particular weather condition. Okay, so from this state transition diagram, we can able to understand, so what are all the probability of occurrence for each scenarios. Okay, for example, from probability of occurrence from sunny condition to rainy condition, it is 0.15. Now we will check, so if you take the probability for sunny condition, so one occurrence is 0.8, next one is 0.05, next one is 0.15. If you sum all these things, the result will be 1. Okay, the entire probability of occurrence for this particular state is 1. See here, 0.8 plus 0.15 plus 0.05, it is 1. Similarly, if you take the rainy condition, if you sum all the probability of occurrence in this particular condition, it will be equal to 1. 0.6, then 0.2, that is 0.8. Again, okay, it is 0.02. Okay, so this is 0.38. So it will be 0.02. Okay, so the answer will be 1. Similarly, if you take from cloudy, it is 0.75, 0.05, that is 0.8, and if you same event, it is 0.2. So if you add all these things, it will come to 0.2. So these probabilities, we are calling it as transmission or transition probability. Okay, and also one more thing it will be mentioned, that is initial probability. Okay, for example, if you take, okay, sunny, rainy, cloudy. Okay, we can mention it as 0.75 and 0.6, similarly 0.2. So this is the initial probability distribution. For example, the initial state will be sunny. In that condition, the probability of occurrence of initial state to be sunny is 0.75. Similarly, the probability of occurrence of initial state to be rainy is 0.6. So this is initial probability distribution. Okay, so next what we have to draw? We have to draw the transition probability matrix. So we have to draw the transition probability matrix. So what are all the states? There are 3 states. From the transition diagram, you can draw the transition probability matrix. So for our, so there are 3 states. I am giving in a short notation. So rainy, cloudy. Similarly, sunny, rainy, cloudy. So these are all present state. Okay, so this we are calling it as future state. Now I am drawing the matrix, that is transition probability matrix. So using the state transition diagram, I am going to write the transition probability matrix. So what is the probability for occurrence for the next state should be sunny as the current state is sunny. If you see here, this is the probability is 0.8. Okay. So what is the probability of occurrence of next state is rainy from sunny? It is 0.15. Similarly, what is the probability of occurrence of next state to be cloudy from the sunny? It is 0.05. Okay, suppose if you add all these things, you will get the result as 1. Okay, the entire probability distribution will be equal to 1. Similarly, for the second case, take the rainy to sunny. What is that? 0.38. Rainy to rainy, it is 0.6. Similarly, rainy to cloudy, it is 0.02. Okay, similarly, you can write for from the cloud to sunny, it is 0.75. Okay, from cloud to rainy, it is 0.05. From cloud to cloud, it is 0.2. Okay, in each case, if you add all these things, you will get the resultant value as 1. Okay, so this matrix we are calling it as transition matrix. Now one more matrix is there, that is the emission probability matrix. So in the transition, each transition or each state diagram, okay, so sorry, in a state transition diagram, for each state, it will emit some evidence. This is what we have discussed, right? So this is called as emission probability or observation likelihood. We can mention any one of the things. We can call it as emission probability or observation likelihood. So in such situation, sunny situation, the probability of wearing coat, the probability of using umbrella, the probability of using shorts, okay, some dresses. Okay, now we will see. So shorts, it is more common, 0.6. Okay, for coat it is 0.3 and umbrella it is 0.1. Similarly, for each state we will see here. Okay, so coat, umbrella and shorts. Okay, for cloudy 0, 0.5, 0.5. Similarly, for rainy also I am writing. So coat, umbrella and shorts. Okay, so 0.3, 0.3, 0.65. Next one is 0.05. 0.05. Yes, 0.05. Okay, so this is called as emission probability. Now from the state transition diagram, I am going to write the next one, that is emission probability. Okay, so what are all the three observable states? One is, we can write coat, umbrella and shorts. Okay, so three conditions I am writing: sunny, rainy, cloudy. Okay, so now in sunny condition, the probability of wearing coat is 0.3. Okay, so the probability of using umbrella is 0.1 and probability of wearing shorts is 0.6. If you add all the probability, again if you check, the result will be 1. Okay, similarly for rainy condition also I am writing. Okay, the probability of wearing during rainy condition, the probability of wearing coat is 0.3. The probability of using umbrella is 0.65 maximum, and probability of wearing shorts is 0.05. So if you add all these probabilities, you will get the answer as 1. Okay, similarly for a cloudy condition also you write it. For shorts it is 0, remaining thing 0.5, 0.5. Okay, so now for the given weather condition example, so I have written, okay, so already given the initial probability distribution. From the state transition diagram, I have written transition probability matrix and also emission probability matrix. Now, okay, so now what is the expected condition? Okay, in hidden Markov model, in general, we used to have three different things. Okay, one is initial probability distribution, we are having transition probability, we are having emission probability. So in such scenario, we have to use these three conditions, okay, the HMM model will try to predict the distribution of event in the hidden state if the observable state is given. Okay, so I hope you understand the process. For example, in other words, if you use any deep learning or machine learning algorithms, first we will go for training step and then we will go for validation and testing step, right? The model will do that process. Similarly, hidden Markov model, okay, so if you give the data, okay, that is in the machine learning model, it will do the training and then it will go for testing. Similarly, in hidden Markov model, if three distributions are given, initial probability distribution, transition probability distribution, and emission probability distribution. If you give these three distribution probability distribution from the observable state, it will find out the hidden state. Probability of occurrence of the sequence of hidden state, it will try to predict it very accurately, these kind of models. Okay. So now, for example, we will see some cases. Okay. So here we are having few terms. Okay. How many different states are there? Sunny, rainy, and cloudy. Three different states are there. That should be mentioned by the term called N. Okay. Next one. Okay. So in each case, how many different observations are there? Okay, that is also 3. That is mentioned by the letter T. Okay. Now from that, okay, so we don't know how many sequence of hidden state is there, in what sequence is there. So we have to find out the maximum combination. Okay, so how to find out the maximum combination? That can be found by the formula N of T. So 3 raised to 3, it is 27 different combinations. Okay, so I hope you understood. Okay, so the expectation is I have to find out the hidden state. Probability of occurrence of the hidden state, that is sequence of state that is hidden. Okay, so only thing I am having is the observable state and also some probability distribution. So from there I am going to find out the sequence of event that is hidden. So that's why we are calling such model as hidden Markov model. Okay, so first step we have to find it out the number of possible combinations of sequence of states. Okay, so in order to find it out, first we have to check how many different states are there. From the state transition diagram, I am checking one state is sunny, another state is rainy, third state is cloudy. So there are 3 different states. And also I have to check how many different observable states are there, observable events are there in each state. So here coat, umbrella and short. So 3 different observables I can able to get it from each state. Okay, that I am mentioning it as T equal to 3. So using these 2 values, I am going to find out how many maximum combinations will be available for this particular sequence of events. So the formula is n raised to the power t. So 3 of 3 is the total value is 27. Okay. So there may be sequence like sunny, sunny, rainy, it will go like that. Or otherwise sunny, rainy, cloudy. Okay. Similarly like that, there are different 27 combinations are there. Now how to find out which one will be the possible state? So we are going to take the probability of all combinations. So which probability of occurrence have the highest value? We are saying that is the state occur in that particular sequence. Okay. So this is what the hidden Markov model will work. Okay. Now how will you find it out? For example, okay, so we take the normal case. Okay, so for our, okay, so I am erasing this one, sorry. This is required 0.75, 0.6, 0.0, 0.2. This is required. Okay. Okay, that is the, so this one. Okay, so now I am going to find the sequence or find the probability of distribution of events for one such scenario, so that we can able to find out all the different cases. That is, in this example, 27 different cases we have to find out the probability, and after that we have to check for which sequence of event the probability value is higher. We can say this is the most predictable sequence of events from the hidden state. Okay, so I am taking one state sunny, next sequence is rainy, and the next sequence is cloudy. Okay, so, and the case is given coat, umbrella. Sorry, technical issue. Okay, so I will quickly recollect. So we are discussing the hidden Markov model. Okay, so in the hidden Markov model, from the observable state, we have to find it out the hidden states, sequence of events. Okay, so how we are going to find out? From the state transition diagram, we are going to build, or we are going to construct, so transition probability matrix, and then we are going to find out emission probability matrix, and also we are using initial probability distribution. Using these three steps, we are going to predict, so which is the most probable sequence of events occur by analyzing the observable state. Here, this is observable state and this is hidden state. Okay, so there are three different states are there: sunny, rainy and cloudy. So the n value, capital N value is 3, and also there are three different observable conditions. The t value is also 3. How to find the number of combination, maximum combinations? N raised to the power 3, t, it is 3 raised to the power 3, it is 27. Okay, Now we are going to see how to find the probability for one such combination. Okay. So now we will write. So we already discussed about joint probability, how to write the joint probability. What is the formula? P of A B equal to P of B tends to A into P of A. This we very well know. Okay. Now I am applying for this one. The probability of a sunny and coat equal to probability of wearing coat if the condition is sunny and the probability of occurrence of the condition sunny. Okay, this is for one small event in that particular sequence. Now I am going to write for the entire case. Okay, now I am going to write for the entire case. For example, I am writing P of, okay, so in short I am writing coat. Okay, second sequence also observable is also coat. Third is umbrella. Okay, then I am writing three states in order: sunny, rainy, and cloudy. Okay, now how we can split using chain rule? We very well known, right? So it is equal to probability of coat. Okay, so probability of coat. So if the case is sunny, first one, sunny, into, similarly for second case I am writing probability of wearing coat if the case is rainy. Similarly for the third case, probability of using umbrella if the case is cloudy. If the case is cloudy. Okay, now one part of the formula is over, that is this part is over. Now I have to write this part. Okay, so initial case it is sunny, so I can write as it is. Okay, probability of sunny, because it is an initial condition independent event. Okay, next when I am writing for this one, how I can write? Probability of rainy if the previous condition is sunny. Similarly, probability of cloudy if the previous condition is rainy. Okay, now, so from this we will find out the probability. Okay, so here if you take this one, okay, so if you take this one, this can be commonly written as pi of probability, because we are doing product of all the probabilities, right? So probability of all the products, okay, so Q of I if it belongs to, if the previous state occurs, into, okay, this is transition matrix. Okay, then what is this? Emission matrix, because we are going to find the observable state. What is this? Pi of pi. Okay, so we are going to use O of I, and if the state is Q of I. Okay, that means, okay, this is observable state, I am mentioning it is by O, and this is hidden state, I am representing it is by Q. Okay, so together, okay, so we are calling it as P of O and Q. Okay, so this is the general formula to find or predict the occurrence of sequence of states that is hidden using hidden Markov model. Okay, now if you substitute, okay, so these three we can able to find it using emission probability. Okay, so the probability of wearing coat if the given condition is sunny, so it is 0.3. Okay, so I am using 0.3 into the probability of wearing coat if it is rainy, it is again 0.3. Okay, so I am using 0.3. Similarly, I am substituting probability of wearing umbrella in the case of cloudy. In the case of cloudy, the probability of using umbrella is 0.5. Okay, so I am writing 0.5 into. Okay, this is how I will get the probability of such particular sequence. Similarly, you have to go for calculate all the different combinations. So finally, which one will comes the largest one? we will choose that particular sequence state. Okay, so this is what the hidden Markov model. Now we will see few more problems so that you will understand better. Okay, so I am not going to erase that one state transition diagram I have done. Okay. So while doing hidden Markov model, we can able to find out hidden state using the observable state, or we can able to find the observable state using the hidden state if the three matrices or the three probabilities are given. One is initial probability, and next one is transition probability, and next one is emission probability. So these three probabilities are important to predict the occurrence of states, that is hidden, or to predict the observable states. Okay, now we will see one example. So problem. So I will read the question. Given that today weather condition is sunny, okay, what is the probability that tomorrow weather condition is sunny and day after tomorrow is rainy? Okay, so today present state is sunny. Okay, now you have to predict for tomorrow. Tomorrow the state should be sunny, and also you have to find it out the day after tomorrow. Day after tomorrow, the probability of occurrence of the weather condition day after tomorrow, whether it may be rainy. Okay, the present state sunny, I am taking it as T, or I am mentioning it as T1. Okay, so it is sunny. So all the future I am writing in the right side. Okay, so T2, that is tomorrow, the probability of occurrence of the tomorrow state, whether it is sunny. Similarly, for T3, I am writing the day after tomorrow, the probability of occurrence of rainy. So now how will you find out using Markov model? Okay, so how will you write the formula? So probability of occurrence of T of 3, okay, then comma T of 2 if the present condition is given. Okay, so understood? Okay, so what is T of 3? That is rainy. T of 2 is sunny. Present state is also sunny. Now you can split this particular formula. So how will you split this particular formula? So T of 3 equal to R if the given state is T of, okay, so what is the given state? Present state is T2. T2 equal to S, because we very well known what is the Markov assumption. The prediction of future state depends upon the present state. It does not depend upon the past state. Okay, so here for day after tomorrow, which is the present, tomorrow is the present. Okay, that's what I am writing here. So day after tomorrow, for predicting the day after tomorrow is rainy state, given that current state is sunny, into probability of occurrence of T of 2 equal to sunny if the given state is T of 1 equal to sunny. Okay, now from the probability transition matrix, I am going to find it out. Okay, so here when you find it out, what is the event? From sunny to rainy, it is 0.15. Okay, next one, sunny to sunny, it is 0.8. If you multiply these two, this is the probability of occurrence. I hope you understood. Okay, so we will see one more problem. Okay, so I hope you understood this problem, right? Similarly, we will see one more problem so that you will understand better. So next one, given that today weather condition is cloudy, okay, the present state is cloudy, okay, and yesterday the weather condition was rainy, okay, yesterday past state is rainy, okay. So now what is the probability that tomorrow is going to be sunny? Okay, so here three different states are given. Present state is cloudy. Today the present condition, weather condition is cloudy, and yesterday the weather condition is rainy. So what is the probability that tomorrow the weather condition will be sunny. So here what is the present state? I am writing it as T1, that is C. So what is the future state? I have to predict, that is sunny. So what is the past state? T0 equal to rainy. Okay. So now from this you have to write the formula. Okay. So for sunny, so our condition is to find out the sunny. Okay, that is probability of occurrence of T2 equal to S. Okay, T1 equal to C is given and T0 equal to rainy is also given. Okay, now again I am going to split it. So how I can split? P of T2 equal to S given that T1 equal to C into P of T1 equal to C and T0 equal to R. Okay, so I will check one. Yes. Okay, only one condition, we have to follow the Markov assumption. What is Markov assumption or Markov property? The prediction of future state depends upon the present state. It won't depend upon the past state. Okay, that is very, very important. So I split the formula mathematical equation on that Markov assumption model. So now we will check the transition probability matrix. So what is the next state will be sunny from cloudy? It is 0.75. Writing here 0.75 into what is the probability of occurrence of next state is cloudy if the previous state is rainy. From rainy to cloudy it is 0.02. If you multiply these two, you will get the answer for the occurrence of tomorrow weather condition will be sunny. Okay. Okay. Now, okay, so final example we will see, then we will close this particular session. Okay, so final one, what is the probability of occurrence of the given series S, R, 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 similarly C, C. So this is a sequence of events. Okay, the question is, what is the probability of occurrence of the given sequence of events? The initial state is sunny, from that next sequence of state is rainy, from that again next sequence of state is rainy, rainy, cloudy, cloudy. So how to find it out? Now write the same formula. Okay, so using chain rule. What about the first step? It is the initial state. So it is an independent event. So write as it is. What about the next one? The future state depends upon the present state. Probability of R if the present state is sunny. What about for the next one? Probability of occurrence of R if the present state is rainy. Similarly, what about for this condition? Probability of occurrence of rainy if the present state is rainy. What about for this one? Probability of occurrence of cloud if the present state is rainy. Similarly, probability of occurrence of cloud if the present state is cloud. Now, what about for this one? This is initial probability distribution. Okay. Now you come for the initial probability distribution. This is for sunny, rainy, cloudy. So I am taking this value and I am substituting here. So it is 0.75. Now I am checking the transition matrix for the next one. All the remaining one, we have to check the transition probability matrix. From sunny to rainy. From sunny to rainy, it is 0.15. 0.15. Similarly, from rainy to rainy, it is 0.6. Okay. Similarly, for rainy to rainy, it is 0.6. From rainy to cloud, it is 0.02. Similarly, from cloud to cloud, it is 0.2. If you multiply all this probability, okay, so you will get the value. So that will be the number of probability of occurrence of such given states. Okay. So today we have discussed about the concept of Markov model and also we have discussed the concept of hidden Markov model. Okay, so I will quickly summarize what we have discussed so far. So 1 minute, let it be on. Okay, so today we have discussed about the hidden Markov model. Okay, and where it is used. I already told, right? So while going for part of speech tagging, okay, so we will get the observable state as some sentence. From that, the hidden state is POS tagging, that will be with individual words. So in order to find out these kind of activities, we used to go for the well-defined model, that is hidden Markov model. These are all few examples given. Okay, and we have discussed about what is Markov chain and what is Markov assumption, that is Markov model, sorry, Markov property, as well as we also discussed about Markov process. Okay, if any sequence of events that follows Markov assumption, we are calling such chain of events as Markov chain. So what is Markov assumption? Okay, the probability of predicting the future depends only on the present. So this is what important. It depends only on the present. It does not depends upon the past event. Okay, this is given by the formula. We already discussed this one. P of Q of I, that is the probability of occurrence of the future event depends upon the present event. Okay. So when you talk about Markov model. So when you talk about Markov model, okay, it consists of three important terms. One is number of states, that is mentioned by n. Okay, so we already discussed. Then it consists of transition probability matrix. Okay, it will be derived from the state transition diagram. Okay, and also it consists of initial probability distribution. When you talk about Markov model, it consists of these three components. One is number of states, and next one is transition probability matrix and initial probability matrix. Okay, so when you talk about hidden Markov model, okay, so we already discussed it is used to predict the number of sequence of events that occur in the hidden as hidden by using the observable states. Okay, so what are all the major components it contains? It contains number of states, n states, as like Markov model. It consists of transition probability matrix as like Markov model. What is the difference? It also contains emission probabilities matrix, or we are calling it as observation likelihood. So this is one of the addition that will be used in the hidden Markov model when compared to Markov model. Okay, and it also has initial probability distribution. Okay, these are all the major components. Using that, we used to predict the number of or sequence of occurrence of states that is in general hidden. Okay, by using the emission evidence, it will able to find out the hidden state. So that's why we are calling such Markov model as hidden Markov model. Okay, these are all the Markov assumption. It will also follow the same condition, Markov assumptions. So these are all examples we already discussed. Okay, so whenever we talk about steps, it has initialization, recursion step, and termination. Okay, so all these things we have discussed in this particular session. Okay, so I'm stopping here. Okay, so in this session, we have discussed about what is Markov model first, what is Markov chain, what is Markov assumption or Markov property, and what is Markov process. So from that, we have discussed what is hidden Markov model, what are all the concepts, major components used in hidden Markov model?